Now, in the last video, that thing we made to find all possible outcomes if a couple has 3 kids, that was called a tree diagram. So tree diagrams are very helpful for finding all possible outcomes. So, all right, new question. Let A represent the event the couple has 2 boys and a girl. I ask, is A simple event? So in other words, what I'm asking is, can A be broken down further? Can A be broken up into other events? So, first of all, you have to think about what this question is asking. The couple has 2 boys and a girl. Now you got to say, wait, does that mean they have 2 boys first and then a girl? If that's what this question was saying, then the answer would be yes, this is a simple event. Boy, boy, followed by girl. Now, if someone just said this, though, in plain language, if somebody was just wondering, gee, I wonder what the probability is of having 2 boys and a girl, they probably wouldn't be talking about having a boy, followed by a girl. So my interpretation of this sentence is the one you would have if you were just having a regular conversation with somebody. If someone says, hey, gee, I wonder what the probability is of having 2 boys and a girl, I would say, well, no, in this case, A is not a simple event. A is not a simple event. The reason is it can be broken up into 3 simple events. So A can be broken up into the events boy, boy, girl, boy, girl, boy, and girl, boy, boy. There are 3 different ways the couple could have 2 boys and a girl. And so the way in which we phrase problems in this class will be very important. So on exams and stuff, I will try to do my best to make sure that the problem isn't ambiguous. And if you're ever confused, you can always just come on up and ask me. So there's a big difference between saying the couple has 2 boys and a girl versus saying the couple has 2 boys and then a girl. Anyway, now I ask, well, what's the probability of A happening? So a shorthand, lazy way of writing that is P of A. P with parentheses and A means probability of A. All right? Well, this is like the marble problem. A little bit, if we think back. So, 8 different things could happen. These are the 8 things that could happen if a couple has 3 kids. Now, there are 3 different ways a couple could have 2 boys and a girl. They could have boy, boy, girl. They could have boy, girl, boy. Or they could have girl, boy, boy. So there are 3 ways to have 2 boys and a girl out of 8 possibilities. This is like saying there are 3 ways to get a blue marble out of a bag of 8 marbles. So the probability is 3 out of 8, or 3/8. If you convert to a decimal, that'd be 0.375. If you convert to a percentage, that would be 37.5%. All of those would be acceptable answers. So, yeah, you got to think about this like it being the marble problem. 8 things could happen. It's like there are 8 marbles in a bag. We want to know what's the probability of getting any of these 3 marbles. So, all right. Now, Bob is about to flip a coin. He says that there are 3 possible outcomes if he flips a coin. Bob says the coin could land heads up, the coin could land tails up, or the coin could land on its edge. He then says that the probability of the coin landing on its edge is 1 out of 3, or 1/3. What's wrong with his reasoning? Now, think about what it would mean to say the probability of a coin landing on its edge is 1/3. You'd be saying that about 1 in every 3 times that you flip a coin, it lands on its edge. Now, that clearly is not right. So, Bob must be making some mistake here. The mistake is this. these three outcomes are not all equally likely to happen. So, the probability that the coin lands heads up is not going to be the same as the probability that the coin lands on its edge. So, these three outcomes do not all have the same chance of happening. All right. So, all right, by the way, for now until the end of the course, there are only two things that can happen if you flip a coin. It's either going to land heads up or tails up. This is the last time we're going to think about a coin being able to land on its edge. So, don't worry about that in the future. All right. So, if A is an event and all simple events are equally likely to occur, we see that the probability of A is calculated as follows. So, like in the marble problem, there is one way to draw a red marble, there are 5 marbles. So the probability is 1 in 5. So if all outcomes are equally likely to happen, the way you find the probability of an event is happening is you find all ways the event can happen and divide by the total number of things that could happen. Like the probability of getting 2 boys and a girl. We figured out all the ways we could have 2 boys and a girl, and we divided by the 8 possible things that could happen, and we got 3/8. So this is the formula that we used in the marble problem and in part C of the question about children. Bob incorrectly applied this formula in the last problem. So Bob couldn't use this formula that we got here because not all outcomes were equally likely to happen. It's not equally as likely for a coin to land on its edge as it is to land heads up. Now, another way of writing this formula is sometimes described as the number of ways for success divided by the number of ways for success plus the number of ways for failure. Some people just state it as, okay, probability of A happening, it's given by the successes over the successes plus failures. One other way sometimes that I'll refer to, you could think of it as desired outcomes over total possible outcomes, or total outcomes. All right. So let's revisit the marble problem. There are 5 marbles in a bag, 4 are blue and 1 is red. Let A be the event drawing a red marble from the bag. Let A with a bar over it represent the event not drawing a marble from the bag. So this symbol here, A with a bar over it, is called the complement of event A. So if you see A with a line over the top, you call it A complement, and it means you're referring to the event A does not happen.